How's that? Now I can see you. But now I can't walk around very much, but I'll just wave my arms erratically to make up for it. How about that? All right, so we're going to talk about bypassing the Android permission model. And this is kind of an old talk, and you can blame this little conference that you may or may not have ever heard of. It's this small, obscure little conference that nobody cares about called DEF CON that's happening next week, or not next week, but next month. And so I saved my new research for them, for which I completely regret because they rejected it. So I would love to show you new research, but this was already on the program. So if you sit through this, I promise next year I'll show you all O-Days for the entire hour if you invite me back. So give me good reviews on your little sheets if you have them. So anyway, I'm Georgia, and I do smartphone stuff, and I taught a class earlier this week, and I own this little company called Bulb Security. So let's talk about the Android. So does anybody here have a smartphone? Smartphone, hands up. All right, I'd like you all to stand up, and I want you to walk to the back of the room and find the nearest dustbin and throw that thing away. No more smartphones. We are not going to use them anymore because they are not smart. And until we start standing up to the vendors and saying, we want more security, they're going to continue to not be smart. So if we all stop using them and go back to using those little Nokia phones that don't even have a touch screen, then everything will be great. So that's what I want you to do. Throw them away. Except I don't really mean that because I have 3 smartphones and I could never throw them away. I'm completely addicted to them. Being here in France and not having data on my phone except when I'm on Wi-Fi is killing me. I'm starting to get the shakes from not being near my smartphone at all times. So I understand if you don't want to throw it away completely. All right. So my first question, before we get into the deep research here, is the permission model of Android actually working? This is, after all, the main security mechanism Android has in place to protect its users, is this idea of a security model of permissions. So users accept permissions. If a user does not accept the permissions, they can't run the app. But if they do accept the permissions, they've opened themselves up to these potentially dangerous functionalities. Is this model actually stopping users from accepting evil permissions? I'm going to read you the permissions from an app, and then you're going to guess what app it is. All right, if it loads on my phone. All right, this app would like access to your personal information. It wants to be able to read all of your contacts that you have on there. So that's your contacts in your phone book, as well as in any of your email accounts you have synced. So if you have your work email, it has access to those as well. You can also write that contact data, so it can delete your address book if it wants to. Big one here in big bold letters is called services that cost you money. I don't know about you guys, but when stuff starts costing me money, I generally stand up and take notice. But this comes right out and says, this can cost you money. And it has the ability to send SMS messages, so it can send text messages, as many as it wants, to as many numbers as it wants, including toll numbers like to, I don't know, prostitutes on the internet or something who have 900 numbers. I'm not really sure how that works. I've never engaged in pay-per-text activity, but I've heard it can be a really big thing these days. So this app can send such messages on your behalf, so messages you didn't send, showing up on your bill. We've allowed the app to do that. It also has access to my messages. It can edit SMS or MMS, so if I'm sending a message on the way out, it could actually change it if it wanted to. It can send them on my behalf, of course, from before. It can read my SMSs. It can actually receive them, so it can see my SMS messages. So any text message that comes to me, it can see it first, and it may or may not ever send it to me on the app screen, so I may never see that message. If any of you are familiar with my first work with the Android botnet, that's exactly how that worked. It stole your SMS messages, but it was doing it at the baseband layer of the phone. This is at the actual application layer. Any app that asks for that permission can intercept SMS and stop it from going to you if they want to. So it makes it really easy to build a botnet at the very least. It also wants access to my location, so anytime I turn on the GPS, which I get lost a lot, so I find myself just paying the bill for the GPS when I go somewhere, like here in Paris. If I get lost, I can't live without my GPS, so I turn it on, find out where I am, find out where I'm going, turn it back off. But during that time, any app could have seen that now I'm in Paris, France. This would be a good time to go rob my house, because I'm obviously not going to be back anytime soon if I'm in Paris, France, because I'm from the US, so that's a long way. It also wants access to my accounts, so all the accounts I have on my phone. Since this is an Android phone, I have a Google account attached to it, but I also have a Twitter account attached to it. Some of my trolling Twitter accounts, some of Jason's Twitter accounts are also attached to it. So any account I have on there, it has access to. It has access to the login information for it, and it can act as an account authenticator, so it can access all that token information, log into those accounts, and it could change anything on there it wanted, really. It could lock me out of my own accounts if it wanted to. It has access to the storage, so it can modify and delete the USB storage contents. So anything that's on my SD card, it can read, it can delete it if it wants to, it can change it. This might be a good thing. There was recently a startup in California that's made a lot of money that its job is to go in every day and delete all of the pictures that you took on your phone while out at the bar drunk. So I could see why this would actually be useful, especially at these conferences where we all take silly pictures of ourselves. Nobody's laughing. I'm obviously not funny. I'll stop. I'll be real serious from now on. It also wants to make phone calls, so it can make phone calls on my behalf. It can also read the phone state and identity. When you see read the phone state and identity, it's like, what does that even mean? Is that really important? And that gets by users all the time, because that phone state and identity is reading the private data of the phone, its actual personal identification number. You can think of that as the credit card of the phone. It's worth about as much to an attacker, so about 10 cents, so about nothing. But if you have millions of them, then it becomes very powerful. So this is how you could actually clone somebody's SIM card and clone their phone, is with that IMEI number, this personal identification number. So it's amazing that apps ask for that and that Google allows them to do so. It also wants system tools to prevent my phone from sleeping. So if you have an Android phone, you could see why that could be a big problem. I mean, 5 hours after I start using the thing, I need to put it on the charger. It's really annoying. That's the only way iPhone is better, in my opinion, is if the battery actually lasts longer. So I don't like apps that want to keep my phone awake. And finally, it wants access to network communications. It wants to be able to use the internet. Can anybody guess what app this is? Right here?
A video game?
A video game. That's a good... It does have video games in it, but think about what's the most popular app ever. If you had to guess, what would it be? Facebook. Let me introduce you to the most popular Android app of all time, loved by all, and recently making a lot and lots of money, much more than me. And it asks for all of those permissions. And you know, I was in college when Facebook first came out, and you had to have a .edu email address, and you had to be all cool to use Facebook, and it was just a new thing that was going to change the world, and nobody believed it. I guess they were right, but now everybody's on Facebook. So I love me some Facebook. I've had Facebook since 2005, long time, love it, completely indoctrinated, can't live without it. But I've had it on my computer since 2005. It needs access to the internet. It can't send SMS messages. It can't look at my GPS. It can't act as an account authenticator, at least I hope not. You never know with Facebook. And it still works fine. So why does it need all of these permissions to work on my phone when it can work over the network just fine on my computer? Theoretically, apps are supposed to be like dumbed down versions of things that are able to work on mobile devices, not all this extra stuff. So I always pick on Facebook. I have to say that I've read all of the source code of Facebook, more on that later, and I will say that they're not doing anything particularly evil. Not anything with permissions anyways. Most of these they don't even use. They just ask for them, because that seems to be what developers do. They just ask for every permission available. I always wondered why that was, but since I became an Android developer, I've realized exactly why that is. It's because if you forget to ask for a permission, it doesn't do a very good job of telling you when it dies and crashes because it doesn't have a permission why it did it, and you can spend a lot of time debugging when it's something simple, like you didn't ask for the permission to do it. So it's just easier as a developer to ask for everything, and then you forget to take it off at the end. So I think that's why this happens. But so basically, if this is the most popular Android app, most downloaded, most installed, I would say no. The answer to my question is absolutely not. the permission model is not working. Because if users will accept this from Facebook, they're going to accept it from anybody. They're going to accept it from me, and you should never accept unnecessary risk from an Android hacker. So before we continue, I want to spend like a little minute talking about Bouncer, which is the newest and greatest thing in terms of Android App Store security. I guess it's called Google Play now. They changed the name of their store. But they now have something that supposedly, and to some extent does, try and catch malware in the Android store. However, catching malware is really hard. This is a problem that has never been solved. Have we seen antivirus lately? Does it catch everything? Of course not. And neither does this. But its job is when you submit something to the Android store, what it actually does is it runs some dynamic and static analysis on it, but it's completely bypassable. A recent talk at SummerCon in New York went through all of this. Charlie Miller and John Oberheide, the Android hackers who have been banned from every marketplace imaginable. They are not even allowed. Charlie Miller's wife couldn't sign up for the Android store. That's how bad it is. They do so many evil things, but they were able to bypass it very easily. You can tell that you're running in Bouncer. You could just do VM awareness the same way malware does on a PC. If you're running in a VM, don't do it. So detect you're in Bouncer and then don't do anything evil. Also, it only runs it for 5 minutes. So don't do anything evil for 6 minutes and you'll get past Bouncer. And it isn't going to flag something just based on your permissions. I submitted something to Bouncer that asked for every single permission but didn't actually do anything evil. It went right through. So based on the permission model, that's not going to get you caught by Bouncer. You're still going to get through. If you submit something like Droid Dream, then yes, you may get caught. I did send just as proof of concept exploit, but it was a known exploit, and it did catch it, as well it should, because Lookout and other antivirus programs should. So it needs to be at least that good, or else it would just be embarrassing. So Bouncer is not very mature yet. You should not be afraid of Bouncer. I know that the malware writers are not, so that doesn't really change our story here, despite the fact that it came out after I wrote this stuff. All right, so naturally I got to thinking about apps after I looked at Facebook, and I was like, really, what's going on here with all these app permissions? So my natural reaction as a hacker was, I'm going to write my own malicious Android app to, one, see how long it takes me to do this. I'm not a very good Java programmer. I had to do it in grad school. I nearly failed out. I'm not really good at it. I'm much more of a Python, maybe C kind of girl. So Java, not so much. So given that I'm not good at Java, I've never written an Android app before, how hard would it be for me to pick this up? So how hard would it be for a beginning malware writer to write it? And what about the changes in Android? And given the Android permission model, would it be hard for me to do malicious things with these permissions that Facebook asked for? Are there controls in place to stop me from doing blatantly malicious things with these permissions? Or once I have the ability to send SMS, can I send any SMS I want as maliciously and blatantly as possible? So those were my questions. So let's see what I came up with. Evil app. That's a good name for a video. Sadly, Bouncer doesn't catch evilapp.apk either. You'd think they'd read the title. All right, so what I have here is my Android phone. I have a little pointer for that. My Android phone and my iPhone. And I have an app called Hello Android. And these are the permissions it asks for. It wants to read my contact data. So it wants to be able to read my contacts, send SMSs, and read that phone state and identity, so the IMEI number. So it says, it puts up a screen here. It could do anything. It could be a game. It could be nothing. It says, hi, Android, I'm an evil app. These are all the evil things I just did to you. Have a good day, basically. So it stole your contacts. It stole your IMEI. If I go to my sent messages, I see no sent messages. So as far as the user knows, no SMS message was even sent. But if I come over to my iPhone, and good luck trying to clone this IMEI. People always try and do it, so I'm just going to tell you it won't work. It's a fake. But that's the IMEI number sent off the phone via text message. So I in no way exploited this phone. I didn't do a root exploit on it. I just asked for the permissions, and I stole your personal data just like that. because you gave me access to it. I asked for the permission to read the IMEI number by that read phone state and identity. I asked for permission to read your contacts by read contacts, and I asked permission to send SMS. All three of those permissions are asked for by Facebook, and I would say probably about 90 to 95% of the other apps on your phone. We'll look at how to audit your phone later in the talk, but you might be surprised at what your phone is actually capable of, just like that. So my answer to my question was, it's really easy. All right, so again, my 3 permissions, which is a lot less than Facebook. Actually, as we'll see when we look at malware samples, we should think, or Bouncer, I want to tell Bouncer, if you see an app that doesn't have very many permissions, that's when it's malware. So when we look at malware samples, we'll see they only have like 3 or 4 permissions, as opposed to real apps that have like 12. So this only had 3, and it abused all of them and managed to steal your personal data. And what really gets me is that it didn't show up in the sent folder with SMS. If it at least showed up in your sent folder, then it would give the user some indication that something had happened. But just by default, I didn't have to change anything to make it do that. By default, it doesn't show up in the sent folder. So I didn't really do anything malicious here. I just used the functionality that was built in. I went on Google and said, how do I send an SMS on Android without alerting the user? And they're like, oh, that's easy. Just send an SMS. It won't alert the user. It's like, okay, that's easy. So yeah, the answer is very, very simple. And we didn't have to root anything again. We didn't exploit it. We just used the permission model. But some of you may have seen things like this. We've got Super One-Click over here, Z4 Root over here. As a side note, these are not malicious programs. Both of these programs have been posting their source code on the internet since the beginning. You can audit all of it. You can see what they're doing. They do exactly what they say they're going to do. They exploit your phone, and then they install super user, and then they go away. They don't run any malicious payloads of their own. They don't call back to a command and control server. They're not out there to hurt you, which is good, because a lot of the rooting programs we're going to look at actually do. And this is where we really get the users, because everybody wants to root their phone. It's cool and awesome to have control of your devices. As well you should. If you pay all this money for the device, you should be able to use it as a toaster if you want to. And you should certainly be able to tether off of it. I don't know if you guys have this problem here, but in the United States, all of the carriers, they don't want to let you run your computer through the internet connection of your phone without paying more money, and I think that's ridiculous. So everybody has to root their phone in order to do so for free. So everybody's rooting their phone because hotel internet is expensive. If you've been to this hotel, I'm sure you've noticed this. €9 a day? Really? God. So yeah. You want to use your phone internet connection, and you want it to be free, so you root your phone with one of these programs out here. The problem is your average end user doesn't really know how to do research on what are the right programs for me to use. If I go to superoneclick.com, what if I end up at Super One Click with a 0 in it and get something that looks an awful lot like Super One Click? Since the source code is available, I can just download it, repackage Super One Click, but then after it does the rooting, installs super user and gives the user exactly what they want, root permissions, so they can tether and they don't have to deal with internet fascists anymore, then it does something else malicious in the background. It steals your information like I just showed, or it calls back to a command and control server and becomes part of the botnet. Again, all completely oblivious to the user here. The user won't see this happening. They make it so easy for that. So there's not really anything to stop anybody from putting out a root. One example of a malicious root that you may have heard of, this was in the news a lot. It was not the first malware outbreak for Android, but it was the first that showed up in the official Android marketplace, which we all know is so secure, because before they had Bouncer back then, there wasn't really anything. You could upload any malicious thing you wanted. And before this even came out, before Droid Dream happened, like almost a year before Droid Dream happened, some researchers did a talk and said, you know, we can upload anything we want to the Android market. We can have it run new code. We can have it call home and get new code at any time, make your phone part of a botnet, and make it really easy to do this. But nobody listened and said that would never happen. Nobody's ever going to do that in real life. So then Droid Dream happened and people finally started to wise up. Not that anything's changed really, you can still put malware in the Android market, you just can't run any malicious activity for 5 minutes. So, are we moving in the right direction? Yes. Have we gotten there? Certainly not. So Droid Dream just looked normal. This is bowling time. There were about 15 variants. Some of them included adult websites, so I used the bowling time one that's just a game. Maybe I should use the adult website one, who knows. But so you could either play a game, find a date, various other things, depending on your variant of Droid Dream. These just look like normal apps, because in fact they were normal apps. Basically, the people who wrote Droid Dream reversed a bunch of apps that were on the market and rebuilt them with something malicious in them. Of course, if you run Droid Dream now, if you download one of these variants from a malware site for analysis, any of your antiviruses, like Lookout here, will immediately say, "This is Droid Dream. You should not run this. Uninstall, please." As well it should, but it's also a 2-year-old piece of malware, so I certainly hope so. So, as I said, I've been telling Google this for ages, and they don't believe me, they just laugh at me, but you can tell when an app is malicious based on the permissions. Droid Dream only asks for 4. That's not normal for an application. They always want about 12 to 15. So you can really tell when somebody's malicious. I'm completely kidding, but it's kind of true. This does seem to be the case. So Droid Dream asked for the ability to use the internet, so it needed to check in for its command and control server when it first installed. So it wanted to be able to use the internet. It wanted that read phone state, so that's to read the IMEI number. It actually checked in using the IMEI number, which a lot of apps do, which is why they all ask for it, and it's a really bad practice. I mean, if you were signing up for a website and you knew for a fact that they were using your credit card number as the unique identifier on you, that when you logged in, it had that in the session, would you think that was a good idea? No, you'd think that's a terrible idea. But that's exactly what a lot of app developers do, and Google does nothing about it. They're like, what's the only unique way to identify the phone? Oh, the IMEI number is always unique. We'll just use that. That's terrible. They shouldn't do that. It's like using the credit card. But Droid Dream did that, but of course, no one thought anything of it because all the apps are doing that, really. I can't sit on this thing anymore. It's making my knees hurt too much. I'll just kind of stand to the side here so you can see me. It also wanted to be able to change the Wi-Fi state and access the Wi-Fi state, and those 2 permissions were just so it could run one of the exploits. One of the exploits that it tried to run needed to toggle on and off the wireless in order to make the shell hit, so that's why it had those. So really not a pretty scary looking permission model here comparatively to, say, Facebook. You'd think, this can't really hurt me very much. It can send my IMEI over the internet, but they're all doing that anyways, so that's not really scary. And it can turn on the Wi-Fi. So, worst comes to worst here, it makes my phone actually cheaper because it's attaching to Wi-Fi randomly. So I guess if you had a malicious access point, but still, comparatively to that stuff we saw with Facebook, this looks pretty benign. So, this is what the user sees. Droid Dream, it works normally. I can play bowling with this all day long and nothing will seem remotely wrong to me. It will work perfectly. Because it actually has the source code of the original app in it. What it does is actually launch the original app when it starts, but then it launches malicious stuff in the background. So it launches the original app and then launches all the nasty stuff in the background at the same time. So it basically has 2 threads. So this one is completely unaffected. So you'll never notice anything wrong here. It runs normally. But all this nonsense going on in the background, you'll never see that either. So what Droid Dream actually did for rooting is it used the same exploits that the white hat rooting at the time was using. It used the exact same code, really, as Z4mod. If you look at the source code for Z4mod at the time, or still, because that's the only one they used, it used the Rage Against the Cage exploit, which is what Droid Dream did. So if you reverse a Droid Dream app, you can tell just by the names of the variables and stuff that they basically just copied the source code. So the people who wrote Droid Dream may not have even been smart enough to write their own exploits. They just stole somebody else's. Because it's publicly available on the internet, there's rooting programs everywhere. It's big business rooting. So it tried actually 2 exploits. So if the first one failed, it tried another one. And if both of them failed, it just gave up. But at the time, these were the ones that people were using. Very few people were up to date on it. Basically, if you didn't have a Google phone, which at the time was Nexus 1, you weren't going to be patched. We'll talk more about that momentarily, but this was going to hit about 95 to 97% of the phones. So if they could get you to download it, which it's really easy to get users to download apps. Actually, in Charlie Miller and John Oberheid's recent talk at SummerCon, when they were putting up malicious apps onto the store to get them past Bouncer, they said the hardest problem they had was making apps that users wouldn't download. They tried to make them really unattractive, make them not look fun, put big warnings that say, this is malicious, please don't download this, and people would still download it. So the hardest problem they ran into was not getting users to download it. So getting users to download apps is not really hard at all. And I try and limit myself to apps that I'm using for research purposes, but I definitely feel myself slipping. I'm like, oh, these apps are so cool. Let's download them and put them on my phone. So it can be a real addiction. I don't really blame the users for this. So you get them to download it. They run exploits against you, the exact same exploits that are being run by the rooting programs, except they do something malicious afterwards. And when you root the phone, the permission model breaks down entirely. So that brings us back to these guys. Like I said, these guys aren't malicious. Their source code is out there. They're not malicious at all. They do what they say they're going to do. Give you the ability to tether your phone for free. Yeah. Hacker rights. Come on, laugh. They don't think I'm funny here. But again, I can repackage this exactly like Droid Dream did with their bowling time, repackage it with malicious stuff in there. Except it's even easier in this case because the exploit's already in here. I don't have to figure out how to run an exploit. It's already doing that. I just have to change something at the end to make it do something malicious for me. So what Droid Dream actually did for the payload, after they had put in the malicious code and they were like, okay, now I have complete control of the phone, the permission model has completely broken down. I can now do whatever I want because I'm root, and root on a Linux 6 system equals I can do whatever I want. So no permission model anymore. I can now send SMSs if I want. I am no longer constrained by those 4 permissions that I asked for. It installed a system level app that continued to have root always. It would steal your personal data and it would send it via the internet or SMS to a CNC server. So it would basically just spy on you, which in terms of malware is not particularly advanced. We've seen malware that does a lot worse things than this, but this was pretty much the beginning of Android malware. So, and these people didn't really seem to be that smart from reading their code. They really did just seem to steal other people's code and put it inside of an app, and that's what they did. So it takes all kinds, I guess. So, mitigations for this. What we can actually do to fix this. For one, users need to update their phones, but that's easier said than done. I never thought I would say anything nice about Microsoft ever, but Microsoft's patching program is not so bad. You know, on Tuesday, if you have automatic updates on, you lose all your work on all of your open games because you left it on overnight and didn't save, and then it restarted. But now your computer is up to date, and that's that, and it's over. And everybody who has Windows will get these updates if they have the automatic updates on. And then it's just, that's that. Not so with the Android. If you have a phone that's put out directly by Google, so you're me and a few other people, so if you have Nexus 1, Nexus S, and that new one, whatever it's called. I only have the Nexus 1, I'm not cool enough. I wish Google would send me free phones, really. I do so much for their security program, but instead of sending us free phones, they just throw us out of their developer program for life. So, no free phones, alas. But, so users need to update their phones. That's easy. We can make users update them, right? Wrong, we can't because the actual updates are not available for every phone. After Google puts out the new patched firmware, everybody who makes an Android, so all of your other carriers, all of your other makers, so like Samsung and everybody else, they all have to port that patch to their platform, make sure it works with all their default install apps, make sure everything's good, put their tweaks on it, and then maybe if they get around to it or they feel like it at some point, maybe send it out to the users. My mom's friend wanted his phone rooted one day, and I thought, oh, this is going to be hard, I'm going to have to download the really new up-to-date stuff, and it may not work, because, rooting phones gets harder every time. So I got the phone, and it's Android 2.1, and I'm like, are you serious? His carrier had just never pushed it out to him in all this time. It's not like he had automatic updates turned off. I mean, Google has always been the best one in terms of pushing out updates over the air, right? Whereas it used to be you had to plug in the iPhone into the computer to get the update, same way with the BlackBerry. They're both over the air now. But originally, Android was ahead of the game because it just came over the air to you. You didn't have to do anything as a user. It just said, please install this. But this guy had never gotten past Android 2.1. His carrier just didn't push it out to him. And I was originally hacking the G1s when they first came out, the first Android that was so cool. You could run Linux on it. It was an epiphany. But I still have them, and they never pushed out anything past Android 1.6. So any of the exploits after that still work on these phones. So it took me 2 minutes to root this guy's phone. And it would do the same thing for any malware author. If that guy downloaded Droid Dream Now 2 years later and didn't have antivirus, it would still work. He's vulnerable to an O-Day for life because his phone manufacturer isn't updating his phone. And that sucks, because we can tell users to update their phones as much as we want, and they may or may not. User awareness and getting users to patch is hard. We're all subject to it. Java's or Flash players please update me right now. And I'm like, no, I'll do it later. I have to work now. And I'm a security person. So what can we expect of the end user? But in this case, they don't even have a chance. So you got to push out your updates, third-party platforms. You got to support the old phones, because they have this idea that if they don't push out the new ones, then people will upgrade. But it doesn't work that way. Upgrades are expensive. So far we've talked about this guy, little evil, malicious Android in the background, who's out there to do malicious harm to you and steal your data and run up your phone bill and otherwise harm you in any way imaginable. But now we're going to switch gears and talk about this guy. Your average developer has heard these stories about people who put apps up on the Android market, sell them for $1. They get millions and millions of downloads, and then they get to retire to a Caribbean island, and they don't have to work in IT anymore, helping their end users get on the internet and access Facebook every day at work. So this is your average guy, and he may or may not know a lot about secure development. And even if he does, Android's a little bit different. Even if you're excellent at stopping SQL injection, you've written some really great web applications that have no SQL injection, and you've taken my class, so you know all about buffer overflow exploits, and you can stop them from happening. So even if you're used to the regular secure coding, as we're going to look at now, there's a whole new set of issues here with Android that even if you're a great secure developer, if you just don't think about it, you could fall victim to and allow evil guy to steal your permissions. So we're actually going to look at evil guys with no permissions that steal permissions not by rooting the phone and making the permission model break down, but by stealing them from our nice little apps here that, I just want to make a buck here. I can get that, It's hard working in IT. So first off, our first issue is with Android storage. What you might have noticed, as I never said, it wants to be able to read items on the SD card. We never asked for that permission because any application on the phone already has that permission. There was recently a no permission app that came out, and it's like, oh no, not another no permission app. Somebody rooted the phone and then showed they could do a shell. But these people were really cool because instead of stealing permissions and such, like being like me and wanting to be all cool, they actually looked at all the things you can access without asking for permission. So there's actually a fair amount of data that isn't considered like a potentially harmful activity. You have to ask the user for things that could potentially harm them. So it's not like Google doesn't know that people are using these things maliciously. But if they don't think it can harm you in any way, the app doesn't have to ask for their permission. So reading from the SD card is not considered potentially malicious. So reading all the data that's stored on the SD card, that's okay. So in your normal Android storage, by default, it's if I made the file, I'm the only one that can access it. Every application has a different user ID. It's only readable, writable, executable to me, the person who made it. Other applications cannot access my data, and that's good. Except when we store it on our SD card, we run into a little bit of a problem. The SD card is formatted VFAT. If any of you are familiar with VFAT, does anybody know what the permissions are on VFAT? World readable. Everybody can see everything. So no matter what you store there, if I can find the file name of it, and I can go through it, I know how to do ls, so, I can read anything that you store there. You might be surprised at some of the stuff that apps actually store on the SD card. Password files are not a good thing to put here. That's not good at all, especially if you don't encrypt them. Just saying. So naturally, having found all this nonsense running around on the SD card, I thought that I'll see if I can exploit this. So that's what I do. I see something and I'm like, okay, I'm going to write something to exploit it. So I don't just talk theory. I actually build it and see how hard it is for someone out there. And once again, I found out it was not very hard. So I have my two phones again, my Android and my iPhone. Just pointing them out for you in case you can't tell the difference. So I'm going to show you two apps here. So I'm going to have an app that stores things on the SD card that are potentially sensitive, and then one that steals it. So I go to my settings on my phone, and if I go to apps, you may not know this, if you look at the apps section in your settings, you can see all of the permissions your apps ask for. You think once you install it, you never see it again. But if we look at bad file save, it has the ability to write things to the SD card. We do have to ask for that, and to read that IMEI number with the read phone state and identity. So you might can see where I'm going with this. I'm going to read that number and store it on the SD card, which is bad practice. You should not do things like that, because then once it's written to the SD card, any other app can access it, whether or not they have the ability to read the IMEI. So without the ability to read the IMEI, which this does not have, it should not be able to read it, and it certainly should not be able to use its SMS functionality to send it somewhere else. But since we've stored it on the SD card, we can now access it easily. So let's do that. If I get around to it. It's a problem with videos. Who knows what I'm saying in the background right now? Alright, so I call my bad send file, and it says, "Hello Android, I am an evil app." Again, this could be a game, this could be nothing, it could be whatever you want it to be. And it, of course, sends it off. And it again has that IMEI number, which we did not have permission to access. So this is a very simple example. But anything that's stored on the SD card, if it's sensitive, we can get to it without permission. So in this case, IMEI, no permission to get to it. And we did. So now I'm going to break the cardinal rule of HackerCons and actually show you some code very briefly. So what actually happens here, we store sensitive data on the SD card. This is our good guy. This is just our guy who wants to make a buck. He's not trying to exploit you. He's just storing his data on the SD card. So it's world readable. Everybody can read it. So I, as the malicious person who does want to hurt you, who's got horns, discovers how that data is stored and then just accesses it. Because it's world readable, we can do that. And then sends it to the attacker because it had the SMS permission, so it could send it. Code examples. Cardinal rule of hacking cons: don't ever put source code up here because it's boring and makes everybody go to sleep. But luckily, this is really short. This is all it takes. We're talking 10 lines here, really. This is better than any programming assignment I ever had to do in college. So we just store it to the SD card. So we just ask for the IMEI number. We're going to store it in a file called IMEI, which then we just output to that file. So IMEI, that's a great name for a file. I wonder what's in there. So from our bad guy side, we just do the same thing. We open a file on the SD card called IMEI, and we read from it, and then we send an SMS. Pretty straightforward. We're looking at like 15 lines of code for the entire thing. And these slides are online, so I'll make it really easy for you to write malicious apps anyway. Wait, how do we get the source code? How did I know that was named IMEI? It's actually quite simple. This is certainly not a rundown on dynamic analysis or completely reversing Android apps, but given 3 free tools on the internet, we can pretty much get the entire source code of an Android app. And there's a white paper on ExploitDB that explains this with a little malware sample. So the idea is you're going to reverse malware with this. There are much more sophisticated ways to do this, but if you just want to see what an app's up to very quickly, you can do this in 2.5 minutes, which is about how much time we have left on this talk, so hence why we rush. So here's Facebook, all of it, just like that. Here's Droid Dream, which will prove that this is not perfect, because I spent a lot of time trying to figure out what this does before my mother walked by and said, wow, your disassembler sucks. So, my mom figured it out, but I was like, what exactly does that do? Because, yeah, that's it making a mistake. It's not perfect. There are better ways to reverse Android malware, but we as simple beginning malware developers can find this on the internet, can do this, and can find out what your apps are doing. We're certainly going to get the file name IMEI out of it. So, oh, okay, that's what I need to look for. That's the file I'm going to open. So we can assume that attackers have our source code, and security through obscurity doesn't work. So mitigation for this: store things securely, not on the SD card, never in the source code, and never world readable. If you need to share things, there are correct ways to do it. You can share a user ID, you can use a SQLite database, at the very least encrypt stuff. If you look at a lot of apps out there, it's just like, ugh. Because you don't have to go to secure coding school to get on the Android marketplace. You don't have to take a test. You just have to pay $25. Nobody requires you, if you're potentially going to harm all of the Android users in the world by your negligence, there's no test for that. You just get to do it anyways. So just think about this stuff. And then the grandfather of them all, the scariest thing I've ever seen in Android open interfaces. If any of you have actually done any Android coding, it's just a little different than anything else. There's this thing called an intent, which is basically a message that's sent between different components and different applications, and it can put data on it. So you're basically sending a file between stuff just really easily. So you can send data everywhere, and then you can call everybody else's interfaces. So you've got services that don't even have a GUI, so you can call something and it just runs in the background, which sounds like malware to me. And then there's, the ones that do have the GUIs, the activities. So we're talking about a whole new structure here. So again, you put up something that does analysis on Java code to try and find flaws. If it's not written for Android, this stuff is going to completely get by it. You can't put this in Fortify and expect it to do anything. So the great thing about this is that it makes it really easy for beginning developers like me, like a lot of the people writing these apps, to write really cool apps really quickly with very little learning curve. For instance, the example that Google uses is, if I want to use the camera, I don't have to learn how to access the camera to take a picture for my app. I don't have to call the camera and make it take the picture. All I have to do is call the camera app that's already on the phone, tell it, please return the picture to me when the user takes it, and then that's that. So that's by calling another interface. I call the interface of the camera app, and it takes the picture for me. So this is really cool and makes it awesome for developers and for users. If you play with Twitter or anything and you take a picture on the Android, it gives you the option, do I want to upload it to Twitter, to Facebook, anything else? That's another example. It's just sending it to the interface of the other application and telling it what to do. The question is, what else can I send to those interfaces? What can I force these apps to do for me? So naturally I thought, well, I'll try. Evil app. So bad interface. There we go. So I have my 2 phones again. Again, Google should send me some new ones, or at very least some pink cases so they look more attractive. But I've got my Android here, and I'm going to look at 2 applications. after my camera finally focuses the picture. So I go back to apps, and I have SMS broadcast receiver, which is not a broadcast receiver. As we'll see, it's actually an activity because it has a UI, but it could be a broadcast receiver, and it wants to be able to send SMSs. So it's part of a game. It wants to send your scores over SMS so you can be famous for having high scores. This is normal for games. We also have this thing called SMS intent, which has no permissions whatsoever. So it certainly should not be sending SMS messages. No permission. So I actually call SMS intent. Notice I did not call SMS broadcast receiver, I called SMS intent. But what we see up here is SMS broadcast receiver, which is why I made it an activity so you could see the GUI. What SMS intent actually did was call SMS broadcast receiver. But if it was a background process, which sending SMS messages of your high scores for your games generally would just do this in the background, take your high scores, send it to the server, and off you go, you get famous for being the best in the world at Angry Birds, then we just called that and you would have seen nothing. And of course, we get an SMS message because we stole the permission to send SMS. So we called an app that had no permissions, we sent an SMS, because that app actually called an app that had an SMS permission. And that's what we end up with. So again, a very simple, straightforward example. Your malicious ones would be a bit more sophisticated, but it gives you the general idea of what's going on here. So, whoa, why am I on the wrong ones? Okay, that's weird. So, code examples. I just had slides that were doubled, huh? All right, so SMS broadcaster activity. So basically, it has a default thing that it sends. It sends tests to that number. That is one of my numbers, so if you want to pay the toll to get to America, by all means, send me as many messages as you like. I answer all of them. So, but it also will look on an intent. So if somebody else calls it, they call it with an intent. It'll look and see if there's any extra stored data on there, and it'll look for two specific keys, message and number. So it'll say, if you have a number and a message you want me to send, I will send it. Naturally, the writers of this app thought that it was only their app that was going to call it. So they didn't think anything malicious of that. But then I just call it. I call that component name, what it's called, give it message, and give it number, and then I'm done. So don't have your dangerous functionality in open interfaces. Require user action. If I required a user to click OK, this would be over. This wouldn't happen. Apps don't do that. This is me. You can contact me if you have any Android-related questions or any other questions, and you can text my phone numbers that you saw throughout this if you wish. So thank you all for having me.